All right, guys, so now we just finished going over the definitions that we need to move on. So again, here we have, and now we're going to look at some examples. So if you take a look at this diagram, this was a hexagon, now we're going down to a pentagon, a regular pentagon that is inscribed into a circle F. And they want us to find each angle measurement. Now, based on what we know by definitions, every figure, if we draw the radii, okay, all the radii, we know that we construct, again, isosceles triangles. That will always be true because the radii of every circle are equivalent. So BF would have to be equal to FA, and we should all be comfortable with that. Now, if they're asking us to find angle measures, we need to think about how many triangles we can really construct within our circle, within our pentagon. So if I draw every radii of this pentagon, I will have, watch, 1, 2, 3, 4, 5 isosceles triangles. Now, by knowing that, I can easily find angle measurements. Because if I think of this right here, this here is a circle. That circle has 360 degrees with that point there, F. So if I have 5 triangles there, how can I find the measure of one of these central angles? So to find the measure of that central angle, you would take 360 and divide it by the number of sides, and in this case it would be 5. So if I'm looking at that, I have 360 divided by 5, what would a measurement of a central angle be? So if we take a look at that, we do our 360 divided by 5, and you should have 72 degrees. So this here, this angle measurement is 72 degrees. All right. Now, let's take a look at this. So they're asking now, because these are all isosceles triangles, they all have 72 degree measurements there because they're all going to be congruent triangles. When we break a regular polygon into isosceles triangles, all those isosceles triangles will be congruent because if you take a look at this, all of your radii are congruent, and you know that your sides are congruent. You know your sides are congruent because BC has to be congruent to BA, which has to be congruent to AE, which has to be congruent to ED, and so on because it's a regular figure. So all these triangles would be congruent by SSS. So now we know every one of these angles is 72 degrees. Now these are central angles because if I look at that 72, it's a central angle because it is formed by 2 consecutive radii. So if I look at AFB, that's a central angle, that would be 72 degrees. Now if I look at my next angle, so that was AFB, the big angle, that's that. Now if I look at my next angle, which is AFG, that apothem breaks that triangle into 2 smaller triangles. So to find that measurement there, I'm going to take that 72 and I'm going to divide it by 2. So that will be 36 degrees. Now if I have, what is it? Next one is what? GAF. Well, now let's think about this. How do I find GAF? Well, if I know this angle here is 36, how would I find GAF? Well, 36 and the GAF would have to be complementary because we're in a right triangle. 2 acute angles of a right triangle are complementary. So you would take that 90, subtract 36, and you would get this to be 54 degrees. All right? All right, now let's look at our next one. So now we have a regular quadrilateral, which we know is a square. All right, and so we have it inscribed in our circle P. So in the diagram, WXYZ is a square inscribed in circle P. Find the following. Center, right there. Center of our square and our circle is both P. We have radius. The 2 radii that I see drawn, you could have said it's PX, or you could have said PY. We can also add more if need be. Remember, when you're talking about a regular polygon, the radii are drawn from the center to a vertex. So PW could be a radius, and PZ could be the radius. The number of radii will be equivalent to the number of sides when we're talking about radii in a regular polygon. Apothem, right here, right there, PQ. An apothem will be from the center, and it will be perpendicular to one of the sides, and it will split the side into 2 smaller congruent segments. So it will be the perpendicular bisector of the other side, the segment that is the perpendicular bisector from the center to the one of the sides. Central angle. right here, made by two consecutive radii, x, p, y. Now, when they want the measure of x, p, y, they want the measure of my central angle. So again, to find the measure of the central angle, you take that 360 and divide it by the number of sides, which is 4. So that would be itself a 90-degree angle. All right, so that was for our, what? XPY, that central angle. Now, if I want, now it's saying XPQ, so XPQ, right here, that XPQ. Now, if I want XPQ, that means I take that central angle, the apothem will be a bisector of that central angle. I will take that 90, that central angle, divide it by 2, and I would get 45 degrees. Now, if we think about this, if this is 90 and this is 45 degrees, that means it is an isosceles right triangle. So therefore, if this is 45 degrees, the angle PXQ would also have to be equivalent to 45 degrees. Excellent. All right, guys, once you get that, let's flip it over. Now, how does this help us find area? Now, what you guys did is you looked at your area yesterday, and you noticed that if the number of sides of the polygon increased, you approached the area of the circle, meaning the more sides in the polygon, the area of the polygon got closer and closer to the area of the circle. All right, that was our observation yesterday. Now, we want to think of how we did that. So let's think about what we did and the whole logic of it just increased and increased and increased. Now, when we looked at it, and I guess one of those slides, I can't remember which number off the top of my head right now, but it talked about circumference, and it talked about inputting circumference into your formula. So I think it had like A equals 1/2 circumference times R. That was the formula that you guys derived. And when you take a look at that 1/2 circumference times R, they asked you, well, what if you put the circumference in of the circle? What would happen? And when you put it in, and you have your circumference is 2 pi r times r, you would see that the 2 and the 1/2 cancel, and you're left with pi r squared, which is the area of the circle. All right? So you were kind of using this yesterday as an estimation to find the area of a polygon, a regular polygon. But we can actually find that area, and we're going to use the definitions and some of the knowledge that you might have learned yesterday to figure out how. So now let's talk about this. Now, again, we have a center. Now I have a hexagon. We're just starting with a hexagon, but this formula works for every regular polygon, not just a hexagon, every regular polygon. So let's take a look here. I'm going to take that center, I'm going to draw that center, and I'm going to create 2 radii, 2 consecutive radii. Now, because I'm drawing 2 consecutive radii, I know that they are congruent. So we have an isosceles triangle here. All right, so let's take a look at that isosceles triangle, and then I'm going to take a look. I got my center, I have my isosceles triangle, drew 2 radii. I am going to drop an apothem right here. That's A. All right, and this here is going to be S. S representing the sides of my polygon, my regular polygon. Now, we talked about this. We said the number of triangles, number of isosceles triangles that we have in a regular polygon is equivalent to the number of sides. So if I take a look at this, I can start by saying, what is the area of one of the triangles? So if I say, what is the area of one triangle? Let me write that. By looking at what I have here, you know the area of a triangle is 1/2 base times height. So in this case, the height would be the apothem, and the base would be the side. So it would be 1/2 AP. I'm sorry, AS. Apothem times side. Perfect. Now, but we said the number of sides in our triangle is equivalent to the number of triangles. So it doesn't matter. This is just a hexagon, but this, again, is going to work for every single regular polygon, so I want to make sure that I think of it that way. So we know the number of sides equals the number of triangles. And when we think of number of sides, we think of the letter n. N represents usually the number of sides in our polygon. All right? So I usually think of that letter n. All right, we're good. So if I think of that letter n, so I'm taking a look, I got n sides in the triangle. So that's the number of triangles. So if I knew that I had n triangles, to find the area of the polygon, I would do 1/2 apothem times the sides times n, n being the number of sides in the triangle. I'm sorry, sides in the polygon, excuse me. The number of sides in the polygon. Well, wait a minute. If S is the side length, and we know every side length is exactly the same because we have a regular polygon, and n is the number of sides, I would also know that the perimeter of my polygon would be the side length times the number of sides. So I know Sn is the same as the perimeter. So I can now conclude the area of the polygon equals 1/2 the apothem times the perimeter. And let's think about that. Like if you think about your formula up here, you're thinking of circumference and radius as opposed to, in this case, we're thinking the apothem and the perimeter. All right, guys, so that is the actual, not an approximation. Yesterday you worked with approximations. This is the actual formula for the area of a regular polygon. All right, so now let's take a look at this. How can we use this to help us out? Now, I'm going to emphasize we do not have permission to forget. So during these problems, we're going to have to gather some information from previous knowledge that we've learned throughout the year. So let's take a look at example 3. You are decorating the top of a table by covering it with small ceramic tiles. The table is a regular octagon with 15-inch side lengths and a radius of about 19.6 inches. What is the area you are covering? Now, if you notice, every single regular figure I break down into an isosceles triangle. So I don't have to draw this again. All I want to do is I like to draw the isosceles triangle and label the parts there and use that to help me find my area. So now I start off by labeling, okay, so I know this is my isosceles triangle. I know I have an apothem, which right now I don't have. It says the octagon, which has 15-inch side. So I know this is my 15-inch side. And I know my radius is the isosceles, they form the isosceles legs of my triangle. So my radius is 19.6. So I like to label my isosceles triangle and use that to help calculate the area. So now let's think about this. I said if I want to find the area, I'm thinking 1/2 apothem times perimeter. Now, the first thing I can easily find is that perimeter because I know the perimeter of this figure is side length times number of sides. Well, my side length is 15. My number of sides is 8. So 15 times 8, I know my perimeter would be 120 inches. So right off the bat, I have that. All right, guys? Nice and easy. Now, from there, what I have to do now is say, okay, I have to find the apothem. How can I do that? Well, if the apothem is always perpendicular, we're always going to, and this is very important to realize, we're always going to form a right triangle. So all our knowledge about right triangles we can use. Now, if I think that it hits the midpoint of the opposite side, so if I pull out that right triangle, I know this is 19.6, I know this is A, and I know this here is 1/2 of 15, which is 7.5. So I can use my Pythagorean theorem here to calculate A. So let's take a look at this. I can do A squared plus 7.5 squared equals 19.6 squared. Now, if I solve for A here, using that Pythagorean theorem, I get A to be approximately 18.108. That's my apothem. Now, having my apothem and my perimeter, I can plug that into my area formula. I can say area equals 1/2 18.108 times 120. And that means my area would be approximately 1,086,490.497 inches squared. Excellent. All right, guys, let's try number 4. So a regular nonagon is inscribed into a circle with radius 4 units. Find the perimeter and the area of the nonagon. So a nonagon has 9 sides. So right off the bat, I know n equals 9. But here they're only giving me the radius. So I need to find the side length, and I also need to find the apothem. But again, I told you I like to pull out my triangle. I always think it's easier. I know this is 4, this is 4. I drop that apothem, that's A. I need to find my side length. So I need to find S, right? And I'm given 4. But now, there's something we have to recall that we also went over. I can find the angle measurements. All right, guys, so I can find the angle measurements. If I think about this, if this is a nonagon, to find this central angle, the central angle will equal 360 divided by 9, which would be 40 degrees. Now, if that's 40 degrees, that means that whole angle is 40. In my right triangle, this smaller angle in my right triangle would be half of that. So this would be 20. Now, again, I said we don't have the right to forget. So if I know an angle measurement and I know a side of a right triangle, I can use right triangle trigonometry to help me out. So, SOHCAHTOA. So let's start by finding the apothem. If I look at 20, the apothem is adjacent and 4 is my hypotenuse. Adjacent and hypotenuse, I'm using cosine. So I do the cosine of 20 equals equals adjacent, which is A, over 4. So make sure we have if you have your graphing calculator, make sure that you go to mode and that degree is highlighted. And we put in, if I go to multiply by 4, 4 cosine 20. And that's going to give me 3.759. So that's going to be, A is approximately 3.759. Now I have to find S. Well, to find S, I'm going to first find half of S. I'm going to label it X, just that side of that triangle. So in this case, instead of, I could either use Pythagorean theorem or I could use sine. I could use the sine of 20 because X is opposite 20 and 4 is still the hypotenuse. So opposite and hypotenuse, sine of 20 is equivalent to X over 4. So if I plug that into my calculator and I have 4 sine 20, I'm going to get 1.368. So X is approximately 1.368. Now that's X and not S. So I would then multiply that by the number of sides, which is 9. So S would be approximately 12.313. So now I have enough information to find my perimeter, to find my area. So my perimeter is going to be side length times, hold on. I already multiplied by 9. I'm sorry. So if we go here, side length, this 1.368 should have been multiplied by 2. That should have been multiplied by 2 to find S. I'm sorry, guys. 2.736. And then we multiply by 9 to find that perimeter of 24.624 units. Okay, that's the perimeter. Let me make sure you see it. And then to find the area, now that we have our perimeter and our apothem right here, I can say my area is 1/2 times 3.759 times 24.624. So if I put that in my calculator, I should have gotten 46.281 units squared. Excellent. Now what I want you guys to do is I want you to try 5A, B, and C. All right? I want you to try them, and then your assignment for homework assignment is labeled below. If you have any questions, please visit me during my office hours. We have a quiz on Thursday on 11:1 to 11:3, and I will have a review during your class time tomorrow, live on Google Meet. Okay, I will send out the link through Canvas, an announcement. I hope you guys have a great day, and please stop by office hours if you have any questions.